In this video, we're going to look at a tidal power plant. We're going to look at how we can generate electricity using only the movement of water created by the tides. So here we have our tidal power plant. You can see that it's quite a large structure, and we can actually see that it has a road on the top. So this is acting more or less as a bridge. You'll see these types of structures used to block off entire estuaries in areas that have tides of several meters or more. Let's have a look at some of the components. You can see we've got a load of inlets and discharges on this side. We've got a trash rack, which we'll use for picking up bits of rubbish and trees, etc. Anything that might want to go through here and into the penstock and damage our turbine runner. Higher up, we've got something that they call a sluice gate. The sluice gate can be used to start, stop and regulate flow, although it's very ill suited to regulating flow. If you know anything about valves, you'll know that gate valves and ball valves are very ill suited for regulating flow, and that's because they generate a lot of turbulent flow, which creates a lot of vibration. So this sluice gate will actually be used more for starting and stopping flow only. If we go down, we can actually see our turbine. This particular turbine is a bulb turbine. It's a derivative of a propeller type turbine. We can see that it's been cut in half so we can see the internals. We'll have a look at this turbine in a bit more detail later in the video. The most important thing with this turbine though, especially concerning the animation that we're about to see, is this item here, which is known as a wicket gate. You can see it looks a little bit like a fan that's currently closed. We'll return to that in a moment as well. We've then got a propeller and some propeller blades. On the opposite side, we've got much the same setup. We have a sluice gate and we have another trash rack. After that, we go to our inlet or discharge, which will be either a penstock or a draft tube, depending on which way the water is flowing. So let's now talk about how all of this is working. Let's talk about how we generate electricity from the movement of water caused by the tides. So I'll play the animation, and we can see already that the water level on the left-hand side of the screen is gradually increasing. It's increasing because the tide is coming in. The reason that the water level is not increasing on the right-hand side is because the wicket gate was closed. If we zoom in, we can have a look at that. You can see now that it's slightly open, and that was why on the right-hand side of the screen, the water level on the right started to increase. But if we go back a little bit in the animation, I'll see if I can back it up slightly. The wicket gate now is completely closed. There is no flow past the wicket gate from the left-hand side to the right-hand side. Now the tide on the left was increasing. It's paused because we stopped the animation. But if I play the animation again, the tide will increase even more on the left, and you'll see what happens to the wicket gate. The wicket gate now opens and it is fully open. Notice that as the wicket gate opens, water begins to flow immediately due to the height difference between the water on the left and the water on the right. Now you'll need at least a couple of meters in height difference in order to get a relatively decent amount of flow. Once the water is flowing though and the wicket gate is open, it comes along here and it will flow across our turbine runner. Now our turbine runner consists of a series of blades, much like the propeller on a ship. And as the water flows across these blades, we create a pressure difference across the blades. And this pressure difference exerts a force, and this force causes the propeller to rotate. We actually call the force applied torque. The propeller is connected on a common shaft to a rotor. As the propeller rotates, it rotates the generator rotor. That is this component here. And as the generator rotor rotates, it induces current in the generator stator, and when we induce current in the generator stator, we get current flow, and at this point we are generating electricity. I'll play the animation we can see that the propeller is now turning because water is flowing down the penstock across the propeller blades. As it does so, the generator rotor spins, we induce current in the stator, and at this stage we are generating electricity. I've paused the animation. Let's go and see what's happened to the water level and why exactly the water flow has stopped. The reason the water flow has stopped is because the water on the left is at the same height as the water on the right. If the water levels are at the same height on both the left and the right, then there will be no flow. There has to be a difference in elevation between the left and right sides in order that we can have flow. Now the tide came in from the left, which was the ocean, and it filled up our bay on the right. You can think of the bay as being a very, very, very large bathtub. When the tide came in, it filled the bay up, and now what's going to happen is we're going to empty the bay out in order to generate electricity again. So we'll play the animation, and you can see on the left-hand side that the water level is starting to decrease. Once we have a sufficient difference between the elevation on the left and the right, we're going to get flow. We can see now that we've got flow. The wicket gate is open, the propeller is turning, and that is rotating the generator rotor, which is connected on the common shaft. So that is the basic concept of how we generate electricity using tidal power. If you like this video and would like to see more engineering related tutorials, then check out some of the links in the video description area, and if you click on these links, you'll get a special discount price for all of our engineering video courses. If you want to support the channel, then please do like this video or share it on social media, it really does help us out. You can also leave a comment in the comments section, and if you've got any questions, then please just ask, and I will try to respond to you within 48 hours. Thanks very much for your time.